Okay, so today we are going to begin one of my very favorite things to do, algebra. And in order to do algebra, we first have to learn how to combine like terms. So we are going to take what we've learned in our integer unit and start learning algebra, and we're going to start with combining like terms. In order to do that, we have to have some vocabulary. So our first vocabulary is term, and I'm going to go ahead and write that down. So term is parts of an expression that are added together. And I'm going to give you some examples. So here's our example. We have 2a plus 3. This whole thing is a term. The 3 is a term. So parts of an expression that are added together. Our next vocabulary word is like terms, and those are terms that have identical variable parts. So terms that have identical variable parts, and in my notes I'm going to underline identical variable because that is the important part of this definition. So some examples might be, let's do, how about 2x plus 4 plus 5x. In this example, 2x and 5x are like terms because they both have an x. Let's look at another example. In this example, you have 2x squared plus 5x plus 7x. This and this are like terms because the x's are both squared. Even though the 5x has an x, it's not squared, so it's not considered like terms. Our next vocabulary word is equivalent variable expressions. And equivalent variable expressions are expressions that are equal for every value of each variable they contain. Alright, so I wrote down the definition, and that definition has a lot of words, and it may or may not make sense. But let's look at some examples. This is going to be very simple examples because my examples aren't going to contain variables, but I think so we can understand what equivalent variable expressions are, I think that this will help you. So think of, how about 2 plus 4? So we know that 2 plus 4 equals 6. This is an expression, and then 1 plus 5 also equals 6. Those are two expressions that are equivalent or equal. So 2 plus 4, that's an expression, also equals 1 times 6. Those are equivalent expressions. They're not equivalent variable expressions because they don't have a variable in them, but that kind of gives you an idea of what an equivalent expression is. And then just imagine as we take this a little bit further in algebra, we're going to put variables on these and what makes the expressions equal. So it may not make sense to you right now, but it will by the end of our algebra unit. Our next vocabulary word is coefficient, and coefficient is the number that is attached to the variable. So go ahead and write that down. And I put attached in quotation marks. That is not a math word. So let's look at an example. So we have 2x. The number that is attached to the variable is the 2. This is the coefficient. And when we have a number and a variable stuck together, like it is here with no sign in between, that means multiply. So this is really 2 times x. But I've told you mathematicians by nature are lazy, and so when we have shortcuts, we take them. So 2 times x is 2x, and that means to multiply, and that is understood in the mathematic world. Our last vocabulary word is constant term. We usually don't say constant term, we just say constant. And a constant is a term with no variable. So in this example, we have 5x plus 7. 5 is the coefficient. It's attached to the variable, it's being multiplied by the variable, and 7 is our constant. Let's look at another example. So in this example, -4 is my coefficient, and -37 is my constant. And so even though this is a minus sign, it still is part of that term to the right. So the sign to the left is part of it. So it's minus 37, we would say -4a minus 37. But then down here is a -37. Minus and negatives mean the same thing, and that's one of the hardest things to understand. But that sign to the left is part of the term. So let's look at our first example. Our first example says identify the coefficients, constant terms, and like terms of the expression x minus 7 plus 3x minus 1. And I'm just going to go ahead and write down everything that we need to do just to make sure that I don't forget anything. So we need to identify the coefficients, we need to identify the constants, and we need to identify the like terms. So coefficients are the numbers that are attached to the variables. So I look here and I have a x and I have a 3x. Well, it's understood, if I have an x, it's understood to be 1 in front of that x. So my coefficient, even though it's not written, it's understood to be there. So the coefficient of my first term is 1, and then the coefficient of that other term is 3. Then my constants are -7 and -1, and that's what I was talking about in the definition. The sign to the left is part of that term. So even though we say x minus 7 plus 3x minus 1, the constant is -7 and -7 or -7 and -1. Then the like terms, I look at things that match based on variables. So I have an x and 3x. Those both have x's in them, so they are like terms. Then I have -7 and -1. Those are also like terms. They're like terms because they have no variable. So let's look at example 2. Example 2 says simplify the expression 8x minus 2 plus 4x. When I simplify the expression, I ask myself, what matches? So I ask myself what matches according to the variables. So I look at that expression and I have 8x and positive 4x or plus 4x. Those match because they both have an x in them. So that's like saying I have 8 x's in this group and I have 4 x's in this group. How many x's do I have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 x's total. So I've simplified that. I've taken my 8x's and my 4x's and I've combined them for 12x. And then I have that -2. That -2 doesn't match anything. So that expression simplified, 8x minus 2 plus 4x equals 12x minus 2. This is my final answer. So you have some on your own problems to try, and it says identify the coefficients, the constant terms, and like terms of the expression. Then simplify the expression. So go ahead and pause the video and try and do those, and then we'll come back and look at them together. Notice over this side I have written coefficient, constants, and like terms. That just helps me remember what I need to do, so to make sure that I don't forget anything that the problem is asking me to find. So in example 1, we have negative 2n plus 4 minus 3n. The first thing that I need to find are the coefficients. So I look at the numbers that are part of the variable, and I have negative 2 and negative 3. So look, my sign to the left is part of that term. So don't forget your negative. Look at that, and if you've forgotten it, go ahead and write it in. Then my constant is 4. And then my like terms are things that match based on the variable. So in this problem, I have negative 2n and negative 3n. Those are my like terms. And then the last thing I need to do is I need to simplify. So when I simplify that based on the like terms, I have negative 2n and I have negative 3n. So I have negative n, negative n, negative n, negative n, negative n. So I have 1, 2, 3, 4, 5, negative 5n, and then my plus 4 doesn't match with anything. So my simplification of that expression is negative 5n plus 4. Okay, let's look at the next, number 2. My coefficients are numbers that are part of the variable. So in this one, it would be negative 6 and positive 5. I don't need to write the plus sign because it's understood to be positive. Then my constants are terms that don't have variables attached to them. So in this example, 10 and minus 4 or negative 4, it's the same thing, are my constants. And then my like terms are negative 6p and 5p. Then I also have 10 and minus 4 or negative 4. Those are like terms because neither one of them have a variable attached to them. Then simplified, let's see, I'm going to do that one over here. I have negative 6p's. So I'm drawing a picture to help me make sense of it. Then I have 5 positives. So I know that negative and positives cancel each other out. So those cancel each other out. This cancels this one out, and this one cancels this one out. So what am I left with? I'm left with 1 negative p, and mathematicians understand that there's a 1 there, but we don't need to write it. So it's just negative p. Then I have 10 minus 4. So I look at, let me circle what I'm looking at. I look at this right here. These are my constants. I have 10 minus 4, which is plus 6. So that simplified is negative p plus 6. All right, and so let's look at our last example. I'm going to go back to black ink. I need coefficients. My coefficients are numbers that are part of the variable. So here I have 3 and negative 1. My constants are 9 and minus 6 or negative 6. My like terms are 3t and negative t or negative 1t. Then I also have, let's see, 9 and minus 6 or negative 6. So then when I simplify that, here's what I'm looking at. I'm looking at this. So I have 3t minus t That's